one personal note, whenever I open my LinkedIn, sir posts consistently appear on my feed. He writes with remarkable depth and clarity on the software, the hardware, even electronics, robotics, AI, civil engineering, even economics, and entrepreneurship, and even more. And it truly makes you wonder how one person can contribute meaningfully across so many domains, right? But he does, a true inspiration, and he is like, it's like legendary thing. And we are extremely excited and eager to learn from his insights today. And before we begin, I kindly request all of you, all the participants, to keep your microphones muted and stay tuned for an interactive discussion. And we'll have a Q&A session at the end where you will get an opportunity to ask the questions to the speaker. And once again, very warm welcome to everyone. And with this, we move hand over to the Madhusudan sir. Sir, you can handle now. Hello, sir.
Can you hear me?
Hello. Sir. Yeah. No, it's sorry.
Am I audible? Clear?
Yes, sir. You are.
Okay. Hi, everybody. I apologize for keeping you all up on a Friday evening. I'm sure the weekend start, you're all eager to go, but I've been asked to give a talk. I think it's the first anniversary of the Silicon Sandbox. I specifically did not want to make a prepared statement. The purpose of this talk is very simple. One was to give you a brief introduction of where the industry is now on a practical basis, right? What is happening in India, and then tell you where the opportunities are. And the next step would be, what can you learn? How can you prepare yourself to utilize those opportunities, right? So there's a lot of news, people making a lot of claims. So I want to give you a pragmatic view of where we are. See, India has got a long history in electronics, going back to the 60s. Unfortunately, we never created a major product industry in the country. Even though in the 70s and 80s, yeah, we had local designs, like we used to have our own local television brands and other electronics brands. But for some reason in the late 80s, 90s, those disappeared, primarily due to onslaught of products from Asia. And every local brand, some names you might remember, most of the brands probably were there before a lot of you were born. I don't know whether you remember the name of Dynora, Solidaire, and all that. Even computers. In the 80s, early 90s, we had homegrown computers, both PCs and higher-end computers also, like HCL, IKEM, Wipro. All of those went away. All the technology companies became services companies because economically it made more sense. India was not a huge market. And the consumer electronics product companies pretty much disappeared. Right? Now there's a bit of revival. Most of the companies coming here, though, are foreign companies. Still, brands are very limited. You have people like Boat, Noise in the consumer electronics sector. In the mobile phone sector, there's only one major one, Lava. It's increasing. It will slowly increase, but it will take time. But the good news is that electronics manufacturing has come up in a big way in India. Now, the first to come was contract manufacturing, which basically means assembly and testing of various electronic products. I know a lot of people criticize that, saying, hey, this is just soldering, this is just assembly. There is a lot of technology that goes into manufacturing, right? It's just not simply soldering. It's how you control yield in manufacturing, how you solder with quality, how do you test products, how do you build factories, how do you train those people. So contract manufacturing is a huge industry. It's very competitive, so margins are low. But it is an industry that probably has the maximum employment potential. So right from people who are working on the assembly lines to engineers who set up the equipment, engineers who do the various testing procedures, engineers who do yield management. All of that matters. So it has enormous employment opportunity. More importantly, only if the EMS companies first come to India, you will get exposed to a variety of products. Now, imagine, for example, the EMS industry was not there, and you wanted to do a fabulous chip company. Okay, you make a part that goes into, say, an LCD television. Now, assume you get funding both from the government and from the venture capitalist, and you make the part. Now, we have to go sell the part. Now, if India did not have an EMS industry or manufacturing industry, you will have to go to Asia to sell the part. Now, a small little startup without too much of cash, designing a product in India and going to Taiwan and Korea and Japan and Malaysia to sell the part is not going to be easy. Now, at least because of so much of manufacturing is happening, you can actually go to some of the EMS companies and say that, look, I have this part. Is it possible for you to use it in your product? So typically, when an EMS company manufactures a product for a foreign company, the component selection is done by the foreign company. So they'll probably not entertain your request. But at least you know that what components get consumed in India. For example, I think 80-90% of the phones that are sold in India are manufactured in India. All right. So even though a majority of our consumer electronics industry brands are foreign brands, a lot of that manufacturing happens in India. You take televisions, you take mobile phones, anything that is mass market typically gets made in India, including PCs and laptops and tablets. Samsung does a lot of manufacturing in Vietnam and a few other things, but there is huge manufacturing. So now there is potential for a chip company to actually find local customers. So it is important that we have the EMS industry. Okay. Now that the EMS industry is there, the next step is to create industries which can supply components to it. And those are starting to come. And as always, we always started with the lowest end, right? So the first companies that started coming were companies that were doing, mobile phone chargers and other power supply type components. Even items like USB cables, they're passive, but the USB cables still require some manufacturing discipline. You have to test it. You have to test it according to USB specs. Higher end USB cables actually have a small chip inside them for compliance with the USB standard. So even manufacturing USB cables requires electronics engineers, right? And so there is opportunity there also. Not just USB cables, right? HDMI cables and other passive components, inductors, capacitors, those are starting to come. Now we are slowly starting to see chip companies coming. By chip companies, I'm talking both passive and active semiconductors. So there are companies now doing MOSFETs, IGBTs, basically power electronic components, other power supply components, or companies like us, which are providing the IP, which goes into digital chips. So we do the processors, we provide the associated subsystems. Then companies like MindGrow, VLSI, and other people take IP from companies like us and do the final end chips, right? So you first had the EMS companies, then you had companies that did some of the power modules. Now we have chip companies. And we also have companies that are now doing higher end modules. Like a lot of the defense power supplies are, for example, made in India. We have companies doing radar for strategic sector. Medical electronics, the low end, the mid end components are now made in India, right? There are companies doing X-ray machines, companies doing ultrasound scanners, all of that. So the employment opportunity is increasing and the products getting manufactured is increasing. And once you start manufacturing more and more products, what happens is every company, obviously Indian companies, but the foreign companies also say, okay, for the Indian market, if I want to do products, let me design in India. So now you're seeing not just products designed outside India being manufactured in India, you're also now seeing products designed and manufactured in India. Classic example is Maruti, right? Even though it's owned by Suzuki, a lot of the cars that Maruti sells here are designed for the Indian market and manufactured over here. In fact, the Indian subsidiary of Suzuki, Maruti, I think is bigger than its parent, if I'm not mistaken. Used to be. Other companies are starting to see similar things. LG, I think, went for an IPO in India. So the market valuation in India for a lot of the foreign companies, for their Indian subsidiaries in India, actually is turning out to be bigger than the parent. Why? Because we have got more people, the market is bigger, the parent company actually services a smaller market. So designed in India, manufactured in India, products are increasing, both for foreign brands and for the small number of Indian brands we have. So now you have a spectrum of industries. Right? You have contract manufacturers, EMS companies. Then you have chip companies which are starting to design local chips. Once the chip companies have started to come, you're also getting the semiconductor manufacturing companies. Right? So Tata has put up a fab in Gujarat. I think it's a 55 nanometer fab initially, somewhere between 110 to 55. Semiconductor complex has always been there for the past 30 years or so, but they're very low volume, they're only strategic. The mass market volume can be handled only by fabs like Tata. Tata is the first fab. There are some fabs like there is a fab in Indian Institute of Science which does gallium nitride for RF components and power components. But mainstream fab, Tata is the only fab. We will see more and more fabs once we have more and more products coming out of Indian companies. What we have far more in number are the OSAT companies. OSAT companies are the ones that package it. The major ones include, I think, Tata, CG Power, Keynes, and there are a bunch of, I think, smaller ones that are coming. So most of these companies would be fabricating chips for foreign companies to be sold abroad. So they represent opportunities, but they don't really grow the Indian industry unless they're Indian corporates. But now we have seen people like Apple, Intel approach these guys for packaging chips, not only for chips to be sold abroad, but also for chips that potentially will be sold in India also. I mean, India consumes a lot of PCs. We also consume a lot of mobile phones, especially Apple phones, right? So Apple does a lot of manufacturing. Now, Apple is also moving up the value chain in terms of the kind of manufacturing that is being done in India. No chips yet, but at least packaging. So you have EMS companies, you have fabless companies, you have IP companies like ours, you have fabs, and you also have OSAT companies. So there are like about 5 different types of companies. We also have CAD software companies, most of them are foreign, but there are small companies which do ECAD software. It's a small, tiny segment, but it's growing. I hope to see more of that. So that is also one set of the companies that is coming. And the ancillary opportunities are also there. Companies like L&T and other Tata projects have to build these fabs, correct? The civil construction has to happen. So, and that is a special set of skills. Fabs require to be controlled very carefully for vibration, especially if you're in an earthquake-prone zone. And you just can't put a normal pile foundation and build a fab. It requires specialized construction. So you need specialized civil engineers to build fabs who know how to build a fab. And when you build fabs, OSATs, you also need very high purity gases, air. So there's a environmental processing equipment that needs to be supplied, specialty chemicals, recycling of those. So that creates an entire new set of industry. So this is a rough map of where our industry is. It's a huge set of opportunities. So what kind of jobs are there now, right? If you take electronic contract manufacturing, typically the engineers and above would need an electronics or an electrical engineering degree. The people on the assembly floor typically would get trained at an ITI. They go through a certain amount of training. Most of this is being done by the company themselves, but there are government efforts to put up training institutes so that we can train people in electronics assembly, fab management. The government of Tamil Nadu effort that is coming, that's putting up a small test fab next to IIT that's going to be run by the government of Tamil Nadu and IIT Madras. That will train people in fab processes, fab technology, and so on. So there's a bunch of training that happens. It's a great industry to be in, and it's probably the part of the industry that offers maximum job opportunities. When it comes to the classical electronics design in chip companies or in IP companies like us, again, there you need a degree in electronics or electrical. And there is also, when you design consumer electronics products, there is also industrial design. So we also need mechanical engineers. we also need chemical engineers because that goes up, right? So industrial design happens only when you have a thriving product industry, and that is starting to come. One of the well-known companies is a company called Bang ID, owned by a friend of mine out of Bangalore. Go check out their website. So a lot of industrial design happens in India. After all, when you buy something like an iPhone or a Samsung phone, you partly buy it because it looks good, correct? And it's nice to hold. So what material, texture, there's a lot of industrial design that goes into consumer electronics products. So industrial design engineers, mechanical engineers are as important as electronics engineers. I mean, if you're going to design a power supply that sits inside a dabba, then that's okay. There's still some industrial design. But in an object of desire, like an iPhone or a Samsung, or the earbuds that go into your ear, they have to look good also, right? So industrial design plays a major role, and that is a great job opportunity also. When it comes to fab technology, then it gets to be very specialized engineering. So you need chemical engineers, you need electronics engineers, and if you're going to go on the semiconductor side of fab, then you essentially need to be good in device physics. It is just not electronics engineers, right? If you've got a good background in applied physics, those can be excellent candidates for fabs also. The OSAT people tend to be more mechanical and process, industrial engineering type of people. So those branches get good opportunities over there. And all of those cases, mechanical is there. And of course, because all of these have process treatment and all that, chemical engineers, environmental engineers, effluent management, all of that matters, right? All those job opportunities are going to increase. Now, the question that I get asked by everybody is like, what do I study? I have a standard answer. I have told you what are all the branches that are there, right? So every branch has got an opportunity: mechanical engineering, chemical engineering, metallurgy and material science is often neglected in most colleges. It's often the least sought out brand. But guess what? When you do chip packaging, materials engineers and metallurgy engineers are one of the most sought after. To get an NVIDIA chip or a high-end Intel chip or a high-end AMD chip or even an Apple requires packaging multiple silicon dies into one package. Without that, Moore's law has come to it's not come to a halt, but it's slowing down. So there's only so much you can cram into one silicon chip, right? So if you want to build bigger and bigger chips, the only way to do that is to split your design into multiple chips and put them all into one package. And guess what? That's not easy. So when you go to 3D packaging, you're actually overlaying. You'll have a substrate and you'll kind of mount the other silicon die on top. I've seen, I think it's an AMD design where they actually take a RAM chip and they keep the CPU die on top of that. But the area where the CPU die sits on the RAM chip, I think there's not too much of circuitry there. And so they actually use, if I'm not mistaken, the substrate actually part for active logic also. I may be wrong, check it out. But it's very intricate and very, very precise mechanical and electronics engineering. Not at all easy to do, because at such fine tolerances with such high temperatures that are in there, you're talking 50, 60 degrees in such close spaces, the materials engineering is very, very tough. So unless you got top-notch materials engineers, you can't do packaging. But guess what? Whenever somebody thinks of an NVIDIA chip, you think only about AI, ML. You think, okay, I got to be a really good computer science guy or an electronics guy to do that. No, you need the packaging person as much as you need the electronics person, right? So chemical engineers, mechanical engineers, electronic engineers, electrical engineers, process people, every branch, civil engineers, every branch is covered. There's no branch that is not there. And don't think the biological guys are left out, right? You do have organic compounds that are starting to come in. And so that matters too. I have standard advice. Pick your branch of choice. All of them have equal opportunity. Yes, computer science graduates tend to get placed a little better, but only if you're good at it, correct? But the important thing is that you don't have to do anything specialized in your courses. People often say stuff like the syllabus is out of date. To some degree, yes. But in any of these branches, the basics matter. If you take electronics, what was taught to you in electronics 30 years ago is still very much relevant. How a transistor operates has not changed at all, right? So if you're still referring to a book like Millman and Halkias, it's still the same. It's not changed. A transistor has behaved exactly the same 40 years ago as it did now. I mean, ever since the universe came into existence, the laws of physics have not changed, correct? The mistake that I see most students do is they want to take specialized courses with this odd thing saying, we are not ready for a job. We need job-oriented courses. You need to get your basics right. Nobody will recruit you if you don't have your really strong basics, which means your math basics, your calculus basics, your electronics basics, your civil engineering basics, your mechanical engineering. Your basics, the basic knowledge that you have in your field of expertise has to be rock solid. Focus on that. Then you need to understand a little more about your industry to understand how those basics translate into things, right? Then figure out how devices are made. Then it becomes applied. So rather than focusing on job, I'm actually working with one engineering college to change their curriculum, right? So one of the things that we plan to do is to get them to do really good practical projects. Like if you're an electronics engineer, you should know how to build a power supply. You should know how to build an amplifier. You can probably also build an RF amplifier. You can build an op-amp, right? But you need to build these with your bare hands, probably design a small PCB to test it out. When you do these projects, you will learn how to translate your basic knowledge into product engineering. That is the skill that you need when you go for a job. It's not that you will become a top-notch product engineer while you're sitting in college. You will have an appreciation of how you take a collection of engineering techniques and make it into a product. That is not taught well in most engineering colleges, including the top-of-the-line ones, right? So more than saying that you need to be ready. So it doesn't mean that if you're going to go into a company that is doing, say, ultrasound equipment, that you need to know about ultrasound. If you know your basics, electronic circuit theory, how to create a basic circuit, how to test it out, how to design a power supply for that, how to make sure your grounding is proper, right? How to do proper routing so that your signal to noise ratio is pretty high, because if you got a bad design and too much of noise creeps in, then you have a lot of problems, right? Especially in sensitive equipment like oscilloscopes or ultrasound equipment or X-ray, right? So it is your basics that come into play. Now, engineering is not pure science. Engineering is all about knowing a set of techniques, knowing the principles behind those techniques, and figuring out how to apply the right set of techniques into creating a product, right? You're engineering a product. You have your raw material, which is your basic skills, then so that is your ingredients, right? Just like cooking. You take all those ingredients, and how to select the right ingredients and how to put them in the right proportion is how you get a great dish. Engineering is no different, right? So when you design a mobile phone, engineering is about, engineering is always a compromise, okay? Because unless you're building a price unlimited product, but even there you'll have volume restrictions or size restrictions, right? But a typical mobile phone selling for 15,000 rupees means, so normally in high volume, between the cost of manufacturing and the end price, it's 2 to 3x, depending on how many channels it goes through and all that. Assume it is 2x, which means a 15,000 rupee phone would have cost the manufacturer 9,000 rupees to manufacture, correct? So for him to sell a 50,000 rupee phone, his cost of manufacturing has to be 9,000 rupees. 10% say goes for EMS and all that, okay, right? So which means the bill material is probably around 6,000, 6,500 rupees or so. So you have it limited. So when you're designing the phone, you're told that, look, you got a 6,500 rupee budget, design with that. So then you got to select how much money do you put on the display, right? A display could be, do you use an OLED display or an LCD display? What resolution do you want? What is the refresh rate on the thing? If the phone is going to be designed for gaming, ideally you want at least 120 hertz, right? Otherwise, you're going to the latency when you play a game is going to be pretty bad. But if you're going to make a gaming phone, you also need a little bit of memory. You need a slightly faster processor, so you may not fit with that budget, right? So normally, if it is a phone that's going to sell for 15,000 rupees, it's unlikely to be a gaming phone, but it may be able to play some kind of games. So you have to allocate the budget between the processor, the amount of memory, and the display. But then you're forgetting one thing. You put all of this together, the phone heats up. And if you look at the high-end gaming phones, they have vapor cooling, right? They have active cooling. That takes up space, which takes up money. So if you design a gaming phone and just allocate your budget among the components and you forget to do the cooling, then the phone is going to heat up. The product is going to fail in the market. So you have to have a budget for that, right? So product engineering is as much as an exercise in budget management as anything else. It's the right set of compromises. Compromise is not a dirty word, right? Whenever we think of compromise, we say we're giving it up. No, everything in the world has limits. And so you don't have unlimited across all axes. So if a product design, you have to make decision across 5 different axes, there's a limit on each axis, right? So how much you put on each matters. So there is no such thing as a perfect product. There's only such thing as a perfect compromise, right? So when you do engineering, compromise is a good word. It's not a negative word. So the right set of compromises is what makes you a great engineer, correct? So in college, try to build, or if you're an engineer who's working for a company, you want to get into product design, start designing products on your own, at least design virtual products, correct? So then you'll figure out how to make a compromise. What is the right selection? And you can't do those compromises in vacuum. You need to know the market. Every engineer, especially if you're an entrepreneur, needs to know the market well. So don't think you've got a cool idea and think it will sell in the market, right? Go into the market, talk to people, ask your friends if you're designing, say, a gaming phone, continue with that example. Hey, will you pay 15,000 rupees for these features? And somebody will say, no, I won't pay. It's not fast enough. I want these features. Then you'll realize that for a proper gaming phone, it needs to be a 25,000 rupee product, right? So this knowledge comes only if you know the market. And if you're going to be a product designer, you constantly have to be talking with people. You have to be networking, trying to figure out what is selling in the market, what is not selling in the market. It is all of those inputs which go into a great product. Correct? That insight that you get is what matters. So if you're going to thrive in the industry, your basics needs to be good in engineering. Without that, that is the foundation. You cannot build anything on a weak foundation, right? So get your basics right. Whatever math that is needed in your field, you better get that right? For example, if you're going to be a good computer scientist, most computer science students I've seen don't have a good background in first order logic or in type systems. There are theoretical computer science subjects, correct? Theory of computation. There are 3-4 critical subjects in computer science. It's a bit of work, but it's not difficult to learn, right? But nobody puts in that effort. Everybody wants to know how to do C programming or Python programming. You can learn a programming language very, very easily. It's not a big deal. It'll take you about 3 to 6 months. But if you got your theory of programming right, if you know how programming languages work, if you know how compilers work, learning a new language is just a new skill. It's like going into a new neighborhood and figuring out how to get from your house to the neighborhood shop and all that, right? That's a simple skill that you can learn. If you don't have your basics, then you will never go up the ladder. But the basics itself is not enough, right? You need to know how to put all the theory into a practical product and the whole process of engineering. Unfortunately, how to engineer a product is not something that our engineering colleges teach. And ideally, that knowledge should come when you do a project, but most colleges don't pay attention to projects. And even in IITs, I think the projects have been made optional. I don't know how you can graduate an engineer without doing at least 2 to 3 projects, right? Because theory only gets you so far. Unless you apply the theory to a practical product, you can't relate to it and you'll forget about it. All of us go through tons and tons of courses in our engineering colleges. And by the time you graduate, the subjects you have learned in the first year, second year, maybe even third year, you've forgotten because you have no chance to apply it. Correct. So we need to kind of change our curriculum so that whatever you learn, gets applied into actual concrete product design, then it will stay in your head, because unless you use the knowledge that you have learned, your brain is not going to retain it. It's just going to remain superficially, and after you have no use for it, it's like cash in a computer, right? Your brain will just flush that knowledge out. So practice makes perfect. I'm frankly a believer that engineering colleges should reduce the number of courses and go depth instead of trying to teach everything under the sun in the hope that at least one of those courses will be useful to get a job. That's now how the industry works. We can happily train you in anything that we want. But for example, if InCore needs to recruit somebody, we use a language called BlueSpec. We don't require that you be an expert in BlueSpec. If you know Verilog, that's fine. We'll teach you in BlueSpec. But more importantly, your knowledge of digital logic and your knowledge of logic optimization, bit of circuit theory, all of that is very, very important. If you know first order logic, it really helps when you do logic, right? So if your basics are solid, you can learn anything in that field, because you simply have to apply what you already know. If your basics are weak and you've just been taught a set of techniques, you're really not an engineer, you're a technician. You're just being taught a bunch of techniques to apply. When those techniques no longer apply, you can't retrain yourself, because you don't know what those techniques represent. You just been, it's like a lathe operator, right? You're a good lathe operator. You know how to operate the lathe, but you don't know how to build the lathe. You will also know how to machine a particular type of aluminum. All of that you'll know. I'm not saying you're not qualified, but if somebody has to design a new product and they have to come up with a new material, then the lathe operator won't know. Right? The materials guy has to figure all of that, and then he'll tell the lathe operator or CNC machine guy that do this. Correct. So if for a new product to be developed, you need to start from the basics. That is what our colleges are ignoring, or even people in the industry. If you're graduated, if I don't know how many of you are students, how many of you are engineers working in the field, it doesn't matter. If you want to progress in your field, you better revisit your basics and refresh it. If you're an engineer who's already practicing, just dig up some of your old books, brush up your theory, apply it, so that if you want to apply for a new job, you can improve both the quality of jobs that you get, and obviously the salary. Is this sufficient? I mean, I think I've spoken for about half an hour.
Yes, sir.
I thought we can do about not just a plain Q&A, because if somebody has got a relevant question, then I can talk about it in detail.
Sure.
You can ask me anything. Anything in the broad electronics and computing industry.
Hello.
Yeah, please go ahead.
Yeah, sir. My question is that what does an embedded engineer do in InCore? Basically, what does his role is, overall role? And all?
I mean, you know what InCore does, right? We basically develop processors, correct?
Yes, yes.
So an embedded engineer's role involves writing either a bare metal software or RTOS software to, can you mute it, please? Yeah, thank you. His role involves basically writing embedded software. The embedded software could be running either on an FPGA board that is running our CPUs, or it could be a customer chip that has been taped out using our IP, or it could be our test chip also, right? So embedded is a very generic term. I don't know how many people realize. There's no difference in theory between embedded software or higher level software. Embedded simply means a software that runs just next to the processor. Often it runs either bare metal, which means it runs directly on the CPU, or it might be running on top of a small RTOS. Normally, once you put Linux and stuff, it becomes a different system. But An embedded engineer generally has to know a lot more about how the CPU platform he or she is working on does. Often it involves assembly programming. So you need to know how your code is going to run optimally on that particular CPU. Why that matters is embedded software often tends to be timing critical. You need interrupts handled in a particular period of time. And so you should be aware of the machine underneath. And in the embedded world, a lot of things can happen suddenly, right? Because when you're reading, say, from the Ethernet, suddenly data can come from the USB. So you have to multitask and all that. When you're writing application program, things are a lot easier. If you're processing a payroll, you'll say read from the database, do some calculation, right, and all that, right? Conceptually, it is simpler. In an embedded world, a lot of things happen asynchronously. Things are happening simultaneously. You can't predict what happens. Suddenly, somebody will hit a keyboard. You'll get an interrupt. You got to handle that. So this juggling of multiple tasks, but you still have to do things within a time-bound fashion. You don't have much memory to play with. If you're talking about a small microcontroller that goes into, say, your washing machine's front panel, you might only have a few kilobytes of RAM left. All of that is right. So embedded programming is normal programming, but the constraints are pretty severe. Limitation of memory, limitation of resources, working close to the CPU, writing in assembly, asynchronous programming, and a lot of things happening simultaneously. So the embedded world is a world where anything can happen, right? It's not a very ordered world. So it is still programming, except you have to be very flexible as a programmer and you have to be multi-skilled. Of course, if you're working in InCore as an embedded software engineer, you'd be running either on a bare metal code or running on something like Zephyr OS, which is one of our reference OSs. It's a RTOS from the Linux Foundation. But we also do embedded Linux, right? So typically you'll be running bare metal or Zephyr or Linux. There are customers who use other things like free RTOS. It's still C programming, but
Yeah, thank you, sir. And
Yeah.
in chat, we have one question. There
Sure.
is no openings for freshers. I have trained on physical design VLSI, but there
Okay.
no opportunity. Mostly few companies going for on-campus placements, tier 1 colleges only. What about trained people from the institutes?
See, that is a problem. I have no straight answer to that. See, physical design is not a easy area, right? Because you need to have good practice. So I know there are a lot of training institutes. I have not looked into how good each one of them is. I'm just like with any field. I'm sure there are good ones and there are bad ones. We do take freshers in our area, correct? We do take interns. InCore does take interns. We don't take a lot. We take, but we advertise. We take interns. I'm not sure why companies. The problem is, I think most companies doing physical design are either MNCs, large companies, which go only to tier 1 colleges, or they're typically services companies which don't have the luxury of training you, right? So they don't want people on the bench. They want somebody who's trained really well because they need to bill you very quickly. Maximum they can keep you on the bench for say 2 to 3 months. Not an easy problem to solve. My only recourse I offer is, no, it's a problem that needs to be solved. I just can't wash my hands off it. I need to give you some practical advice. But if the training institute that you go to offers something very practical, something that is credible, not just a toy exercise that everybody goes through, then it would be easy to convince a company. One option is that you do have open source tooling available now, right? Open Road and so on. Now you have PDKs available, I think, for open PDKs for 180 nanometers, 130, probably 90 or so, right? It is the only thing I can think of is, as long as you got a reasonable PC, practice it and do some credible examples of a small chip. And if you go talk to somebody like HCL or TESOL or Wipro, show them, look, this is what I've done. Then you'll have a better chance of getting in as a fresher. Otherwise, their problem is, yes, you have learned some physical design in some training institute, but you're still not good enough to be billed. So what do they do with you? Now, I realize the absurdity of their position also, right? If you need more people and there are only so many trained people, obviously, if you need more people, you have to take freshers and train them, right? And so saying that we will take only experienced people or take from tier 1 is not the solution, but unfortunately, that is how the reality is. Ideally, we need better training institutes, but I'm a firm believer in self-training beyond a particular point, because you are more interested in your future than anybody else. So get some open source tools and play with it and become a slightly better PD engineer. I realized that working on PD on a PC and just doing test GDS layout, you're not actually taped anything out, okay? But that is fine. If you know your basics, if you're able to defend some of the decisions you made to an interviewing team, you will get a better chance. But instead of doing a complete chip, my advice would be you take up specific problems in PD, try that out. So when you're talking to an interviewer, you can say that, look, this is the typical problem faced when I'm routing power, and this is how I've handled the problem, right? So if the person interviewing you understands that you are aware of the problems that come in PD, and you know how to solve at least one or two of the basic problems. Nobody is expecting you to be an expert, right? They just want to know that you got your basics right, that you're curious and you're willing to learn. A good company should look only for these things. They should not be looking at the breadth of your knowledge, because by definition, you're a fresher. But are your basics solid? Good. First level pass. Are you willing to learn? Good. Third, have you tried some practical experiments and experimented yourself so that you have motivation? You should be recruitable at that point.
Yeah, thank you, sir. And
Sure.
some of you have raised your hands. You can ask one by one.
Yeah, good evening, sir. Sir, my question is that how to reskill ourselves so that we, to your consideration, as you said that you hire freshers, but what kind of freshers do you actually prefer?
No, we take freshers in digital design. I think we have taken freshers in digital design, in verification, and also for field application engineer. See, fundamentally, we are digital design people, right? So your basics should be very solid in digital design. There are a number of courses in digital design, like I said, right? Logic design. And in the day of open source, especially on front, see, backend is a lot tougher because you need specialized tools and all that. But in front-end design, what prevents you from taking, say, an open source RISC-V CPU, enhancing that? For example, take a CPU and build a faster multiplier. A lot of the engineers we have hired, we have not even looked at their courses. They've done a lot of open source work themselves, and they say that, look, this is what I've done. I go look at their code. Not that I'm going to recruit them just based on the code, but I have something concrete to interview them with, right? Why did you do this design that way? It makes for a very productive and fruitful interview process. So in your field, again, I apologize if I sound like a broken record, get your basics rock solid. And in digital design, which is where we recruit, and a lot of people recruit in digital design, write code, test code, and prove that your code works. There is no substitute to showing that you built something. See, and when you build something, please go depth first. Don't try to create 20 designs and say that I've done all of that, right? Nobody's going to believe you. Take one design, explore it. I'll give you an example. Take multipliers. Take an open source core. You can take the Shakti core, or you can take the Berkeley Rocket core. One of the experiments we did at IIT was, there are multiple types of multipliers, right? Early out multipliers. There are multiple multiplication algorithms. I think you can easily build 12 to 16 different types of multipliers. Build as many multipliers as possible and instantiate each of those multipliers into one of the RISC-V cores and figure out what benefits do you get. Do you get better performance? Do you get better area, right? What benefits? Do that. When you talk to the interviewing committee, tell them, look, I took this RISC-V core, I built 8 multipliers, and this is the table of the pros and cons of each multiplier. I can assure you, you'll be a shoo-in. It's very easy to put in that effort, right? Most of the problem comes because a lot of young engineers, freshers and people in the field don't bother to skill themselves. Forget about reskilling. What was wrong with your skill in the first place? I'm assuming everybody here has got a degree in engineering. Is that a correct assumption?
Yeah, sir. Currently, I'm expecting final year, so I'll be expecting my degree in 26.
Yeah. So everybody has got an engineering degree. Why is this talk of reskilling? What happened to skilling? What happens to all the courses that you're taught? Look here, I know the state of engineering education in this country. Okay, I'm not criticizing anybody. Colleges are overloaded, not enough money, variety, right? So I'm not going to blame anybody. There's no point in blaming people, right? All I'm saying is ultimately it's your life, your future. Okay, you can blame somebody, doesn't help. My standard answer always is go back to your basics. In fact, go back to your first year courses. If you're going to get into CPU design, there are 3-4 courses you can do. There's good old Hennessy and Patterson. Read it end to end. There are enough exercises there. Just work through all the exercises. See, when I went to college back in the mid 80s, there are a lot of material available. If I had to learn C programs, there's like 1 or 2 books available and only copies available in the library. You got to photocopy pages of it and all that. You don't have any of those issues now. You got enough online tutorials, right? All the resource that you need for learning is there. Stanford has got excellent online courses. So you're not stuck with whatever your college is teaching you. You can take online MIT courses. They're free. You can take online Stanford courses. Everything is available. So there is no excuse for you to say that I was not taught properly. Correct? You have to take the initiative. Unfortunately, not everybody is capable of bringing themselves up to speed. I completely realize that. But it's a competitive world, and most colleges don't have great faculty. There's a shortage of good faculty. Unfortunately, that's a reality you have to live with. So you have to bite the bullet and put in that effort, because ultimately the only person who really cares about you is you and your parents, of course, right? So you got to put in that effort. It's not difficult. Get a laptop, get a PC, right? Go through those books, work those exercises, build practical stuff. I can assure you, if your ability to build products with your own hands is good, it's very easy to get a job. But
Yeah,
everybody
thank you.
keeps going into physical design, right? I don't know how many physical design jobs are there. There's actually a shortage of good digital engineers, right? So instead of just going to physical design, try your hand at analog design. There's a huge shortage of analog engineers. Try your hand at RF design. If at all you're going to do physical design, do analog physical design, do RF physical design, right? They are much small designs. They're easier to do at home. Of course, if you're going to do RF and analog and all that, you have to be good in math. That's not a skill that everybody has. You have to be good at SPICE. There are those tools also, right? But all of that goes back to the same thing, right? Get your basics right, and it's not that difficult to get a job.
Happy evening, sir.
Yeah.
So from your experience building a semiconductor company in India as the ecosystem grows, where do you see the maximum long-term value being created? That is in the areas of architecture, design, or verification, or in the areas of manufacturing? And what kind of engineers do you believe will be the hardest to replace for the next decade?
You need all of them here. I see, one of the reasons I started the Shakti project along with Professor Kamakoti was that India had a shortage of CPU architects, correct? So Shakti project had 2 goals. One was to essentially create a pipeline of CPU architects, and a lot of good CPU architects came out of that program, including our co-founder Neil Gala, who's a leading CPU designer. But he started with a master's degree at IIT, then did his PhD and all that, right? So self-taught CPU engineer, top-notch one. So can be done, I think, right? So we need digital designers. We need digital designers. We also, where there is a shortages, there's a shortage of CPU engineers. There's a shortage of analog designers. There's a shortage of RF designers. Every vertical has got, but we need good design engineers. And verification, unfortunately, to me, verification is as difficult as design. Verification doesn't mean running a bunch of tests. Unfortunately, every time people think quality assurance, they just think it is a low-end job. No, a verification architect has to be as good as the design architect, because see, running the test is a menial job and it gets automated. Even creating test cases is getting more and more automated through AI. But to create a verification architecture, to figure out how to verify a CPU, to think about what could go wrong, to think about corner cases, requires a lot of creativity. A design engineer and a verification engineer think very differently. A verification engineer has to be a very skeptical chap, saying, what happens if this goes wrong? What happens if this goes wrong? The design guy says this will work. I mean, how can I prove to myself that this will work? Correct? So there's a slightly different way of thinking that a verification engineer has to be. For me, design engineers and verification engineers are two sides of the same coin. Correct? So you can learn verification, but learn verification methodologies, learn how to create verification architectures. So you need the higher level skills. So design engineers across digital, analog, RF, verification engineers. We need product engineers who can take all of this, and we need SOC engineers, right? SOC engineers need slightly different set of skills than digital engineers. Digital engineers designing a CPU will focus only on the logic. SOC engineers have to deal with complexity. How do I mix one CPU with a DMA controller and the bus and those peripherals, right? So there are tools for that. So SOC engineering is more of a multidisciplinary engineering. We need tons and tons of SOC designers. So there are enough examples. There are SOC building tools that are available. Very easy to build your own SOC. Grab any of the open source cores, take the open source Axi bus, there are enough open source peripherals, put it either.
Hello, sir. I think you are muted. Hello, sir. Sir, I think you are muted.
Is it okay now? Can you hear me?
Yes, sir. You can
Yeah.
continue.
Yeah. So some skills you can self-teach. Some skills, unfortunately, you can't. So depending on which field you're chosen for yourself, see, if it is a skill that you can't self-teach, you have to work for a company, forget about getting a high salary and stuff, right?
It's muted again, sir.
Can you hear me now? Let me join from.
Yes, sir.
Oh, yes, sir.
Yes, sir.
Yeah, okay. I don't know. I'm not doing anything. It's self-muting. I don't know why. I'll switch over to my phone if it keeps happening. So what I'm saying is, if there are things that you want to learn, forget about the salary. Go for an extremely low salary. It doesn't matter if it is something that you want to learn, right? So something like physical design or semiconductor manufacturing process, jobs might be tough to get. So you can compromise on the salary. Don't compromise on the job's ability to teach you things, right? So at least for the first 5-8 years of a career, make sure you learn a lot, learn new things, learn design, correct? Don't salary compare shop and saying that my friend is making so much and I should be right. Focus on learning, focus on something new. See, whatever you learn in the first 10 years is what is going to sustain you for the rest of your career, okay? Because you'll probably learn a lot less once you're in your 30s. Don't waste your 21 to 31 years. Learn as much as possible. If you have to compromise on your quality of life, other things, to the extent possible, of course. If you've got a family to support, medical needs and stuff, obviously you can't take a cut in salary. So it's not a advice that is applicable in all cases, but to the extent possible, focus on learning.
Sure. Thank you, sir. That was very insightful.
Okay. I think we're out of time now. Or I can take more questions.
You can take up some 2 to 3 questions, sir, if
Sure.
you have time.
Yeah, I have time. Not a problem.
Hello, sir.
Yeah, go ahead, please.
Sir, to become a DFT engineer, on which things should I focus? Can you tell us, sir?
I'm not a DFT guy, but there is. See, the way to approach DFT is don't start with saying I need to become a DFT engineer. Correct? See, what is DFT? It's designed for testing, right? So you first need to appreciate the design, right? So take a small design, then you will also know what testing that you have to do, and talk to somebody, talk to a DFT engineer as to what is the limitations of testing on a design that's already done, correct? You need to understand the rationale for DFT. Too many people come and say that I need to do DFT. If I ask them, why do you want to do DFT? There are a lot of jobs in DFT, right? That is the problem. You need to understand why DFT as a field exists. What are the challenges of testing for a design? See, DFT exists because once you have taped out the chip, right, you need to be able to test the chip, right? So you need to, so the product has to be testable. So you need to understand the philosophy of how a chip is tested at various stages. When you're just doing the design in a simulator, how do you test it? How do you test on an FPGA? And after you have done your GDS at the GLS level, what kind of verification you're going to do? And after the chip is taped out, what kind of testing happens, right? You need to have an appreciation of the design. You need to have an appreciation of the testing. Then you can combine the two. Then you'll figure out how to do appropriate DFT, right? Otherwise, you won't understand why a particular DFT technique exists. So if your friend who's an accomplished DFT engineer tells you this is what you do, don't just learn it mechanically as a skill. See, unfortunately, what has happened in the chip industry is that a lot of things are, after RTL design is over, things are automated. Correct? So for DFT, the tool inserts DFT hooks into the design. And I've seen too many engineers who know how to operate the tool, who kind of run through the DFT tool. They know some stuff, but if you don't have an appreciation for what the tool is doing, how it is doing, why it is doing, you'll never become a good DFT engineer. So please understand the rationale behind DFT, understand how to do the techniques, try to see if some of those things you can actually add DFT hooks by hand, something minimal, not easy, and then go use the tool. In the chip industry, like I said, especially after RTL, too many people have just learned how to operate the tool. So somebody tells you, okay, for this chip, this is the process. They give you a process document. You have the parameters, and you just go through the motion. You're no better than somebody who's just soldering a chip, right? And And if you go to a new company and that company has got a different DFT tool, you're unemployable. Whereas if you know the theory behind DFT, you know how it works. A tool is something that a new tool you can learn because you know the theory behind it, you know how it works. So never do something blindly. You're an engineer. You're supposed to know how things work. There is a difference between a technician who operates a piece of equipment and an engineer who knows how to design things. Next question, please, and then I got.
Good evening, sir. Sir, my question is, what kind of project should be done by a college student if he or she have to go in the field of VLSI?
But it depends on which part of VLSI. If you want to do design, just take an open source CPU and hack it, enhance it, add features. If you want to get more into, I would say, if you go to VLSI, always do a design project. And that will help you understand how a design is done.
Good afternoon, sir. Could you explain about the analog side?
Sir, your microphone is muted again.
The web software. Is it okay now?
Yes, sir.
Hello?
Yes,
Yeah,
sir.
yeah. Can you hear me now? Yeah.
Yes,
So
sir.
did I answer your question or?
No, sir, the answer was not audible.
Okay, so can you repeat the question? You're talking about what you, so like I said, design something. Can be very simple circuitry, can be small, tiny CPU. Design and verify. Never just design and leave it at that, right? Design and prove that your design is correct. That will get you a good career in VLSI design.
Sir, like if I want to go into digital design, then from where should I start and go to the end projects?
Take an open source CPU, hack it, enhance it. Standard answer.
Okay.
Either take Shakti
Sir,
or
could you say about?
Huh?
Sir, could you say about the analog side also?
analog design. Like I said, my standard advice for analog is design a
Sir, my key is muted, sir.
again. I don't know why here. I really apologize.
Yes, sir. Now
Yeah.
audible, sir.
Yeah, analog is very easy to do, right? Just get a breadboard, get a few transistors, resistors, do a design. The key thing in analog is make sure you got access to an oscilloscope. Just a plain old analog scope will do. You don't have to do very high-end designs, right? Try a power supply, try an op-amp, try a class A or a class D amplifier. Just these three: power supply, op-amp, audio amplifier. If you're feeling brave, design an RF amplifier.
Okay.
I can assure you, you'll become a good analog guy.
Thank you, sir.
Sir, from your experience, can you tell what PD judgments separate engineers who can tape out silicon from those who can only run tools?
Basically, people who are curious and have learned what the tool does are the ones that succeed. What happens if something goes wrong, correct? See, if the tool does something wrong, you need to know, you need to go behind what the tool has done and fix it. Right? So you need to have an awareness of what the tool does. I'm not saying that everything can be done manually. Obviously, some things can be done only by the tool. But you need to understand the layout process. Starting from synthesis, you need to understand synthesis, right? You need to figure out synthesis artifacts. Synthesis is a bit of a black box, correct? So you need to figure out. By the way, all of this is to some degree stuff that I've learned over the years, but I am a hardcore operating systems and embedded engineer. I'm not a chip guy, okay, but I'm an electronics guy by training. Know the field, okay, but I don't operate these tools. So If some of these advice sounds stupid, I apologize. But all I'm saying is pay attention to what the synthesis tool does. Go through every step of the physical design process. Understand what is happening. Have an appreciation for what the tool does. And then you will get good tape out outcomes. Hey, but tape out is also discipline, right? So a tool is not perfection. For example, if you do timing, a tool may give negative or positive slack, and you have to figure out what is it that you desire. If you're depends on how tight your tolerances are. So, for example, if you're not meeting timing because you have used very power optimized cells, which don't switch as fast, you might be able to use higher power cells only for timing critical portions of the circuit, right? So how do you, but unless your design is hierarchical, that's not so easy to do and all that, right? So, but then, like I said, I'm not a PD guy. I operate at a far higher level in the stack. But these are the kind of things that you need to do. You need to have an appreciation for how the tool does. And a lot of and design decisions are not made by the tool, right? You have to make it. So unless you go through a few iterations of PD, understand what happens. Of course, you want to get a few things wrong here, but it is better to get it wrong on paper than mess up actual tape out, right? Obviously, if you're not an experienced tape out guy, they're not going to trust you with it. There's going to be somebody senior overseeing. But you need to learn. Too many people, like I said, in the industry have just become tool jockeys. They know how to operate the tool. They know how to punch in the parameter, and something comes out to the other end, right? But if something goes wrong, they have no way of figuring out what went wrong. And that is unfortunate.
Hello, sir.
Yeah, go ahead, please.
Sir, I'm an embedded engineer. So, I took a course from CDAC Hyderabad. I completed the course, but
yeah, go ahead. Hello.
hello.
Yeah, go ahead. We lost you.
Sir, yeah, sir. I'm an embedded. I took a embedded course.
Okay.
Hello, Shiva. I think you are muted.
Right now? Yeah. Okay. Sir, after that, what happened is many of my seniors are advising me to that move to VLSI. It has a better growth and salaries and all. I don't know whether I should leave this and move to that, or I just continue searching jobs in this embedded sector. A little bit confused actually.
No. RISC-V embedded is a good area. Okay. RISC-V embedded is a good area. Please stick to it. Learn things like Rust. There is a shortage of good RISC-V embedded engineers. Okay. But if you want to broaden your horizons, I would do not just embedded programming, but also do things like post-silicon testing. See, a lot of the SoC testing is done with embedded software. So if you learn to do embedded, if you start writing embedded software for doing SoC testing and post-silicon testing, great opportunities.
Okay. How much the automation is going to that VLSI side? Will it reduce the jobs in VLSI or
no, not really. For every bit of automation we do, we need writing embedded software is not getting automated anytime soon, I can assure you. Only mundane stuff, right? Yes, automation does reduce jobs in other areas, especially like website design, all of that. I mean, you hardly hire people to do HTML coding now, right? Right. So those kind of things go. At the lowest level, no. Automation helps you. It's a tool that can assist you. But broaden your horizons of what it means to be an embedded engineer. Like I said, get into writing SoC test software, post-silicon validation. But understand an ISA really well. See, focus on one, right? I mean, study both ARM and RISC-V. I will never advise anybody just to do RISC-V, right? If you're embedded, study ARM and RISC-V. Become a master of assembly level programming, both in ARM and RISC-V. It's very easy. Any a RISC-V kit and an ARM kit is 500 rupees, 550 rupees. Yeah. Buy one, attach a USB to your laptop, learn programming. Ultimately, you'll get a job if the code that you have written, especially in open source, is good. There's no magic to it. The easiest field to train yourself is embedded software.
Okay.
It's the easiest field to self-train.
Like many of my like friend or seniors are like brainwashed me like that doesn't have any growth, so just move to VLSI. So, like that little bit made like from last 2 months I was searching
No, but
in
see,
VLSI actually.
yeah, look, see, the problem is if you're a bad engineer, okay, you won't get a job. And bad engineers with a lot of engineers will get even lesser jobs. VLSI demand is more, so even if you're a bad engineer, because demand is there, they may hire you, but you'll never proceed in your career. See, whatever field you choose, be good at it. You will have a good career. There always is a job. Good.
So,
when people talk
Carry
about
on, sir.
embedded engineers, there are not too many good embedded engineers. Okay, just because they write a bit of C code, Linux code doesn't make you a good embedded engineer. So a lot of your seniors are not getting job because possibly, and I'm not casting aspersions. I don't know who they are. I have no idea why they didn't get a job. Usually, it's because you're not good at what you're doing.
Okay. So like how should I like progress in my from now onwards to get a good like if when right now I'm getting like small startups which are like recently I got a startup like it's right just scrolling code right for a scrolling board like.
No, yeah, but how much of code have you written in embedded? How long have you been in the industry?
No, sir. Like I was searching for the jobs actually. Like
No.
recently,
When did you graduate?
like last year, sir.
Yeah, but what are your skills in embedded? How much of code have you written?
Like I in the like in the course like I got like I took training like I got trained over there like I extensively I did.
No, but see, ultimately, look, assume it's a large company, say Intel. Correct? So if they look at you, if you're from a tier 1 college, they think you've got some training. Okay. I am not a firm believer in saying that just because we came from a tier 1 college, you're a better engineer. Okay. But I can't fight that battle here. Unfortunately, society has got some hierarchy, which you or I can't change. That's fine. But if a large company looks at you and you're not from a tier 1 or even one of the better known tier 2 colleges, they assume that you may not be good at what you are. You have to require a lot of training. Okay. How do you change their mind? See, in a half-an-hour interview, you can't prove to them that you can do a lot of things. It's kind of tough, especially because they come with a preconceived notion. They may have biases against people in tier 3 colleges and all that, right? The only way to overcome that is to write code.
Okay.
Teach yourself good embedded programming, write code, put it on GitHub. And when you get called for an interview, show them, this is what I've written. But before you write code, study other people's code. Take a particular area. Like I said, Zephyr programming is in demand now. Learn programming in Zephyr, but write useful device driver. Write a good device driver code. Learn Rust programming. If you write device drivers in Rust, say for Linux, I can assure you, you'll get enough jobs. But you have to put in that effort. You've already been graduated for a year. I don't know what your skills are. Look, somebody interviewing you says, okay, you're from a particular college. You've done some courses. He looks at your grade. Beyond that, he has no way of gauging whether you're going to be a good embedded engineer or not. So just saying you're not getting a job is only half the picture. Put yourself in the shoes of the person interviewing you. Why should he recruit you?
Okay.
Look at the interviewer, right? He's got some 30 people who he has to interview. Everyone has got some decent grades in college. They've all done some courses. They've all done some training. For him, everything sounds the same. So what will he do? He'll discount all of that. and he will try to find some reason to take you or not take you. You are not giving him an extra reason to consider you. Would you agree?
No.
No. Look at it from, imagine you are sitting on the interviewer side, right? Why should he recruit you
Yes.
over somebody else? Unfortunately, it's a competitive world where for every job, they'll probably get hundreds, if not thousands of applications, and they have to select. So you need to do something to stand out. You need to put in that effort. It's hard work. Is it fair? No, it's not fair. But then when was the world ever fair? I'm assuming this is not the answer you're looking for, but what else do you expect me to say? You need, but fundamentally, you look, if it is a discipline in which you have to write code, please write lots of code in open source, publish it before you go for an interview. It makes all the world of difference. Not just write code, right? It should be good code, it should be tested. And when they ask you about the code, you should be able to explain your design decisions. Why did you write that function in that way? If you're writing C code, for example, have you passed data via a pointer, or have you kept it in some global memory, right? Anything, there are a lot of design decisions, right? You should be able to explain why you took a particular design decision. Just like design is about choices. Why you chose a particular algorithm over the other, why you chose a particular technique over the other. If you're able to explain that, then they know that you can reason and you're curious. If you just follow some standard template and write code, then nah.
Okay, sir. Thank you so much.
Sure. Yeah.
Good evening, sir.
Yeah, go ahead.
To
Guys,
become a
last question here, then I got to go.
Yeah,
Also.
sir. You can take this up and we'll wrap for today.
Sure, not a problem. Yeah, go ahead, please.
to become a embedded engineer, what we should do, sir? How to start? Which hopes are which one are for future hopes? Like more job opportunities, like VLSI are embedded, sir.
No, stick to embedded here. A lot of things there. Like I just told the gentleman who talked before you,
Which tools should I learn, sir?
No, learn programming here.
Okay.
Not tools, learn programming. Learn to write embedded code, both for ARM and for RISC-V.
Okay, sir.
See, this is the problem, right? Everybody thinks in terms of tools. It's not about tools. It's about coding. If you don't know coding, people are not going to recruit you. As simple as that.
Last question. Can I have opportunity to ask the last question, sir?
Yeah, go ahead.
Sir, could you explain what is actually happening inside the InCore Semiconductors? You are definitely
Hello.
Sir, am I audible?
Yeah, you kept breaking.
Sorry for the interruption, sir.
No problem.
Sir, my doubt is that whether the InCore is only IPs of digital domain, or they are working also on the analog domain and RF domains.
No. We are purely digital, but we are way more than a lot of people think we do only CPUs. No, we do RISC-V cores. We do the SoC fabrics that go with the core. But more importantly, our key product is a product called SoCgen. So we combine our RISC-V cores and third-party RISC-V cores fabric, take other third-party digital IP, and we construct this SoC. Right? So we are InCore basically automates the building of RISC-V SoCs, and we also provide the appropriate building blocks underneath. So we are a combination of CPU level IP and system level IP.
Yes, sir.
Yeah, go ahead, please.
Sir, I'm a trained fresher in VLSI physical design domain.
Okay.
What is the future opportunities?
Opportunities are there, madam, because every chip has to be physically laid out. The problem comes because the kind of companies that are recruiting, as I pointed out, they immediately want trained people, and there is a bit of disconnect between training people well and getting them jobs. Not an easy problem to solve because the training institutes kind of rush you through a particular curriculum and the industry doesn't feel that is sufficient. Is that a correct?
Yes, sir. I'm
Right?
applying for many companies, but there is no response.
Yeah,
For
look, see, please look at the company also, right? Hundreds of people apply. I don't know what they can do also. The only solution is for the training companies to train you better.
yes,
Unfortunately, they don't train you well.
yes, sir.
That's the problem. And like I said, you can train yourself a bit, but it's not easy to become a better physical design engineer. So too many people get into physical design. I don't know why. And probably I would like to see more people get into Verif, digital design. See, till now, I'll tell you why so many people get into physical design also, right? A lot of the jobs that are coming to India, especially for the services companies, was from synthesis and physical design. So typically you would see the digital verification, DFT, physical design, right? These are the standard
Yes,
things
sir.
that most companies do. But now with startups like us or other product startups, the front end part of the chip design is also becoming prominent in India. So we do need more people in digital design, in verification, in SOC design and SOC verification. So you can, if you're not spend too much time in physical design, you can probably also try a bit in front end design verification also, because there are enough jobs there also. Earlier, those jobs were not there because design was not happening too much in India other than in MNCs. But now a lot of Indian companies are also doing design.
Okay, sir.
Good evening, sir. Hello.
Yeah, go ahead, please.
Hello, sir.
Yeah.
I think we
Sir,
can wrap it up for today.
ma'am, last question, ma'am. Can I?
Yeah, go ahead.
Okay,
Last
okay, you
question.
can go
Yeah.
ahead.
Go ahead, please. Hello.
Hello, Sai Kiran, you can unmute and ask the question.
Hello. Yeah, good evening, sir. I am electrical and electronics engineering student, sir.
Okay.
During our campus placements, I got placed in JSW, sir. It's an electrical role.
Okay.
But I was equally interested in VLSI. So, like, would you give suggestion like it is better to shift to VLSI or after
No,
working
not
in
really.
JSW?
No, yeah. Electrical means, see, why do you think electrical opportunities are not there? For example, how do you think EVs are built? EV cars, EV thing, right? Electrical power management is a huge growth industry in India. See, it is not that the field itself that is bad, and this is what I constantly tell people. It is what you do in the field. Okay. So,
Okay, sir.
what is your role supposed to be in JSW?
It is mentioned like graduate engineer trainee, sir, where I will be working on electrical systems and machines.
No. Are you going to be maintaining them or designing them?
Yeah, I will be maintaining them, sir, using PLC and SCADA softwares.
See, like I said, it is not whether electrical is bad. Electrical is a great field, okay, equally interesting, okay. But
okay, sir.
You need to talk to, I have no idea role. JSW is a great company, but you need to talk to the people who are recruiting you as to whether it is a maintenance job or a design job. Okay. Maintenance is a great job, but design probably can pay you slightly better the more you see. But even a maintenance engineer can switch over to design provided your basics are right. But what happens with the maintenance job is especially electrical maintenance, it is a very critical job. Okay, it's a very important job because you need the electrical systems to keep functioning. You keep doing day-to-day maintenance so much that you forget to reskill yourself. You understand what I'm saying?
Yes,
And
sir.
then
Yes, sir.
you'll get good salary, good job and all that. And after like 5-8 years, you found that you've lost all your theory knowledge and you're stuck doing maintenance.
Okay, sir.
So you need to talk to the person recruiting you to figure out what kind of a job it is and find out if what are the opportunities for designing equipment and so on.
Yeah, it was mentioned like I will be working on softwares like PLC and SCADA, sir, to
No,
maintain
but
electrical and
no, but
electronic.
how much of software writing, all of that is there? Talk to them. Okay, and then
Okay.
find out as to whether you're going to learn anything or you're just going to operate.
Okay, sir. Okay, sir. Thank you, sir. And one more thing, sir. How will be the opportunities when I need to shift from JSW to some VLSI company, sir? Like,
No,
for example.
opportunities are there. Yeah, it is never a problem with an opportunity. The
Okay,
question is, why would somebody recruit you? Your skills need to be good. No,
Yeah,
look,
sir,
it's
yeah.
a competitive world. Yeah, there are 1.4 billion Indians in the country. So
Yeah, sir, yeah.
for every job, unfortunately, there are lots and lots of applicants. That
Yeah,
is reality. Unfortunately, I can't change that.
okay,
But
sir.
I sympathize with all of you guys there. It was never this bad when I grew up. Okay, I don't know whether I would have survived in such a hyper competitive world. It's a simpler world when I grew up and started my career. I have the greatest of sympathies for your generation, and unfortunately, I can't do much about the world. I can only give advice. It might be
Thank you, sir.
terrible
Thank
advice
you.
also. Okay, I'm also pretty old, so okay. Good talking to you, folks. Hope
Yeah.
my talk was of some help for whatever it is worth.
Yeah. Thank you, sir. Thank you for the inputs and
Sure.
also your patience, even though the session got extended.
No
And
problem.
yeah, before we conclude the session for today,
Okay.
I'll take a moment to extend our heartfelt gratitude to you for gracing our anniversary webinar with your presence. Your journey and clarity that you have provided to our audience has truly been inspirational. We are deeply grateful for you, sir. Thank you.
Glad to be.
Hello, sir.
Yeah, go ahead, please. Please go ahead.
So shall we get your email ID for?
Yeah, send me a WhatsApp message and I'll send it across to you.
So we doesn't know your number.
Number, yeah, I don't want to give everybody a public thing. I'm there on LinkedIn. Just send me a connect thing, then I'll connect with you.
Okay, sir. Sure.
Okay.
I have seen you a lot in LinkedIn, sir.
Yeah,
In
just
all
send a
the
connect
comments.
request.
Yes, sir.
I generally always accept connect requests. So
Okay, sir. Thank you, sir.
okay.
Sir, your name?
Oh, my name is S Madhusudan.
Okay, okay, sir.
Okay.
Yeah. Thank you, sir, for this wonderful session.
Yeah.
And thank you all for joining this session. You all can leave now.
Okay.